Welcome to The Explainer, where we break down big ideas. Today, we're tackling a really fascinating puzzle, one that's all about light and color. Okay, so let's just dive right into it. We all know that a prism can take white light and split it into a beautiful rainbow. But can we reverse the process? Can we actually take that rainbow and turn it back into white light? You might be thinking the answer is pretty simple, right? Just use a second prism, turn it upside down, and put it in front of the first one. Seems logical. But that simple, intuitive solution, it completely fails. Like, not even close. Which really begs the question, why? What is going on here? Well, to solve this, we're going to have to investigate the fundamental physics of how light actually behaves. So the core concept we need to understand is called refraction. All that means is that light bends because it actually slows down when it enters a denser material, like going from air into glass. Now here's where it gets really, really interesting. The amount that light slows down and therefore bends depends on its color, or its wavelengths. So this difference in bending is what literally fans the white light out, separating it into all the colors of the rainbow. And that's our problem. The second prism, it does straighten out the light paths, but because the colors are already separated, all it does is create a parallel rainbow beam. It doesn't actually recombine them into white light. So let's see how this all connects. The solution to our little modern puzzle? Well, it's actually been hiding in a 300-year-old book. See, back then, scientists believed that white light was completely pure, and that prisms were somehow staining it with color. But Isaac Newton, he totally disagreed. He wanted to prove that white light was actually made of all the colors, and the only way to do that was to put them all back together again. And he documented his groundbreaking experiment, revealing the key missing piece of our puzzle. The secret, it turns out, was not another prism, but a convex lens. So, how does this lens solve everything? Let's take a look at the final correct setup. And this is it's brilliant. The lens takes all of those fanned-out colors and focuses them all back to one tiny little spot. So at that exact point, all of the colors overlap, they're all in the same place at the same time, and poof, they create white light again. So when you place that second flipped prism at that exact focal point, it catches all the colors at the same time. The prism then unbends the light, and out comes a perfect single beam of white light. The puzzle is solved. The really crucial point here is that this wasn't just some cool light trick. This one experiment changed the course of science. Newton himself called it his experimentum crucis, which is just a fancy way of saying the crucial experiment. It was the one that was going to settle the debate once and for all. And with one elegant demonstration, he completely overturned those old ideas. He proved that white light is a composite, a mixture of all the colors that we see in a rainbow. It really makes you wonder, doesn't it? What other obvious truths that we all believe in today are just, one crucial experiment away from being proven completely wrong?